Let's get going with what is Wireshark. Wireshark is a network packet analyzer, i.e. is a tool for analyzing the packets that transverse on a network. So imagine if you're working away at your desktop and you're connecting to the World Wide Web, you're uploading, downloading websites, files, etc. Your desktop is connected to a switch. Your switch is then connected to a router, and from that router it can leave the corporate network and it goes out to the internet. So your packets are traveling between the various nodes on the network, and at any one of those intersection points, I'm able to capture the traffic and display it with Wireshark. So Wireshark is an application. It runs on your computer, your desktop, your laptop, and what it does is it intercepts and captures the traffic that's passing over the network. And so wherever you connect it is where it's going to start collecting the packets. Not only does it capture it, but it has a wonderful graphical user interface that allows you then to display that data so you can see the content of the packets that are transversing the network. And then what is so cool about Wireshark is it then has a bunch of tools that allow you to sort and filter and analyze that traffic. Over the years, Wireshark has become almost the de facto standard for doing packet analysis of your network. Why has it become so dominant? Is because it's open source. And I can't think of an open source packet analyzer that's available today that is better than Wireshark. Of course, open source means that it's free. There are licensing terms that you have to comply with, but you don't have to pay to buy this software. It is open, which means that there are lots of developers and testers that are looking at that source code. Any issues, they tend to be reported very quickly, and they also tend to be fixed very quickly when something is open source. You see significant contribution from networking experts around the world, and it runs on the major operating systems. The history of the Wireshark application goes all the way back to 1997, so this product has been around a long time. Gerald Coombs is still around today and participating and making major contributions to Wireshark. After Gerald created and released the product, what you start to see is major contributions from the industry, adding dissectors which decode different protocols and compile it in such a way that you can then see the content of those different fields in the protocol. It was renamed in 2006 to Wireshark, and Wireshark 1.0 was formally released in 2008. After 10 years of development effort, Wireshark has just recently been moved to a new platform, the Qt platform, and this provides us with significant performance improvements, and Wireshark 2.0 is the focus of this training course. You will be installing the Wireshark application on your computer, and in order to connect to the network, you need a network interface card, a NIC card, and that NIC card will support a specific protocol, such as you might have an Ethernet NIC card, or you might even have a Wi-Fi NIC card. You'll then have the rest of the protocol stack, and here I'm showing the TCP IP protocol stack, which is normally part of your operating system, and then sitting above that are your applications. Today you might have an email, a browser, etc. as your applications that you run on your computer. And so Wireshark is just another application. But what we need to do is to make sure that the operating system has been enabled to support packet capture. That just means you need to deploy a driver that will allow the OS to capture those packets and then pass them up to the Wireshark application. The Wireshark application will then display those packets and allow you to analyze it. The way a NIC card works today is your packets will come in, and let's say you're using Ethernet. it'll look at the MAC address and say, oh, this is for my computer, and therefore I'll pass it up the protocol stack. Or it'll look at the MAC address and say, this isn't destined for my computer, and then it will discard those packets. If the NIC card discards the packets, then your operating system cannot pass those packets up to the Wireshark layer. So to allow Wireshark to receive packets that are not destined for your computer, we need to put your NIC card into promiscuous mode. In promiscuous mode, the NIC card will pass all traffic up to the CPU, and then we can use our packet capture driver to pass it up to Wireshark. So remember, if you're trying to capture traffic between two network nodes and not traffic that's being sent specifically to your machine, then you need to put your NIC card into promiscuous mode. So at the most simplistic level, you install the Wireshark application on your computer, you connect that workstation to the network, putting it into promiscuous mode, connect it to the network where you wish to capture packets, and then Wireshark will display those packets, and then you can start to sort and filter those packets to see exactly what's going across the network. Now, it's really important that you understand what Wireshark does and what Wireshark does not do. So Wireshark will capture traffic on any network interface. In fact, it will capture traffic on multiple interfaces at the same time, but it does not inject traffic into the network. So it is not a traffic generator. You can't use it to create packets and push them into the network for testing purposes. There is one exception, which I've noted at the bottom of the slide, and it's very important to understand this, is that the only time Wireshark will inject traffic is if you've asked it to do name resolution. Let's say, for instance, I've asked it to resolve the Ethernet MAC address or the Internet Protocol IP address. And the reason I say that's important is that if you are using Wireshark to measure your network's performance, then you would want to turn off name resolution, and in that way Wireshark is not putting any traffic into the network and therefore is not going to impact any performance measurements. Once Wireshark has captured the data, it then provides you a phenomenal, rich set of tools for analyzing those packets that you've captured. But it is not going to take any action on it. So it's not an intrusion prevention system where it will say, oh, I've found this event, therefore I need to do this. Wireshark will display and help you analyze it, but once you've analyzed it, you need to use a different set of mechanisms then to change, reconfigure the network. It does not take any action on the network itself. So what are these amazing tools that Wireshark provides? First, it interprets the ones and zeros that are being sent over the air and says this is the field it is, and then gives you an English description of the field. For example, a source and a destination MAC address. You are going to see both the ones and the zeros and the hex values, as well as the English description of source destination MAC addresses. It allows you to search the packet capture. Maybe you want to search for a specific IP address. Maybe you want to search for a specific string. It will allow you to filter traffic. For example, I just want to filter all of the traffic going to this IP address or all the traffic coming from this IP address. One of the amazing features is the ability to color packets. Let's say I want to color all my ICMP packets so I can start to see if there's any errors being reported on the network. And there are different types of ICMP packets. So maybe I want to color code those that are errors versus carrying information in different colors. And this makes it so much easier for me to see those frames in the packet capture. And one of the best features is the reporting. Always surprised how people underutilize the reporting capabilities, but if you get used to running the reports, you can save yourself an enormous amount of time because it does the analysis for you and then gives you a report. How cool is that? And of course, you'll want to be able to save those packet captures. You'll want to be able to import and export them. So for instance, maybe you want to export them to an Excel spreadsheet. And similarly, you can import packet captures. Maybe you've done a packet capture using the Microsoft Packet Analyzer on a server, and now you want to import them and analyze them using Wireshark.